the recording started. And let me just give you some information, and I have also a question for you. First, I want to tell you that yesterday I realized that there was a bit of mess in my playlist for this course. And so the result is that the list of the video in the playlist was not correct. And yesterday I reordered it, and now the playlist is fine. So if you are looking for the videos of the lectures, now you can go to the playlist and it is fine. Before yesterday, the playlist was not complete, so some videos were missing. They were available in the list of the videos, but not in the playlist. Now everything is fine. I just wanted to tell you that yesterday I fixed this problem, and I would like to thank the student who let me know yesterday that there was this problem. Second issue, I just wanted to ask you if you have any question, any open concern related to the exam. As you know, on Monday, we are closing the course. On Monday, I will give you some additional information regarding basically how the exam takes place. It's not additional, it's just repetition of the information that I provided to you, and it's already displayed in the opening in the web page of our course. And let me just share it, just to give you an idea of what I mean. If you go to the web page of our course, there is everything explained. I am scrolling down, and there is there are some details on the exam. So I will review with you these guidelines, and then I will remind you about the dates, and I will give you also some information on the questions that I may ask, which now I can deliver to you, because of course at the beginning of the course we didn't know any of the topics that we discussed together. So now that we know the topics and we know the details, I can give you some additional information. But before Monday, I just wanted to tell you today, if you have any open issue that you would like to be discussed either today or on Monday regarding the exam, just let me know. Maybe it's better if you let me know in advance, so I get to Monday prepared to discuss the issues that I know that you are interested in. If you don't have any particular question, just let's wait on Monday, and then on Monday you will have another opportunity to discuss. Very good. Now, today I said that I wanted to make a recap of the exercise, and this is precisely what I would like to do now. And the reason why I want to make this recap is that I was very quick in just cutting and pasting the instructions from my proposed code, which is available on the website, and the R console. Again, today, I cannot start RStudio here, so please be patient. Let me just make an attempt whether I could connect to my remote PC. Just 1 second. I need, in order to make this attempt to remote, I need to share the screen. So let me see. Because if I could connect to my remote PC, there wouldn't be problem in sharing the screen and making everything there. Let's see if I can. But I doubt it will be. No, it seems that it works today. So, okay. Let me just see. So RStudio, let's see. RStudio, let me see if it starts. Yeah, okay. Yes. Okay, very good. So I can share the screen of my PC. Just 1 second. I need to close this. Okay. Let me see if I can share the screen of the remote PC, but I guess yes. Okay. Yeah, you can see it. Perfect. Okay, so let me just open even here a Chrome page. So I am, okay. One second. Okay. Okay. Okay, thank you for your patience. So now you see the web page. Let's click on the exercise. Application of pairwise comparison for decision making. It's here. Okay, here I downloaded the zip file. I open it, and this is our R code. So first, let me open the PDF. You remember that it's an application tool of pairwise comparison, and the exercise needs that I put into R these utility functions, which are used to rescale the criteria, the value of the 4 criteria in the range 0, 1. And then I have to basically build a pairwise comparison matrix. And then by working on the matrix, I can estimate the weight and I can estimate the score that is obtained by each alternative. I just would like to kindly remind you, I hope that you took a little bit of time to review this exercise, but here the alternatives are 5 values of design flow of an hydropower plant, a run-of-the-river hydropower plant. So we have this hydropower plant to be designed, and our alternatives are 5 design flows to be evaluated, each alternative according to the criteria that you see here: the economic benefit, the impact on the fish community, the impact on the landscape, and the fruition of the downstream river reach. And these metrics are to be evaluated with these utility functions. Now, I'm going to repeat in RStudio this time the exercise. Remember, please, that we didn't complete the exercise on Thursday because we did everything but the computation of the final score that is gained by each alternative. So we didn't conclude what is the best alternative according to our decision making. I keep the PDF here, but on the other hand, I open the proposed R code, which you can see here. And it's the same code that we used last time. The difference today is that we can use RStudio because I can connect I'm working on my PC remotely. And so in RStudio, what we have to do is to open a script, because we said that in RStudio we prefer to work not on the console, not directly on the console, like we did on Thursday, last Monday. Last Monday we worked directly on the console, which is what you can see on the left part of the screen now. What we want to do in RStudio is to work with a script. Why? Because we already discussed it in the past, because the script is something that you can save. And then you can run the script through the console. But the advantage is that the script, as I said, it's a separate file which contains all the instructions. And of course, even in the console, you can save what you did because you have an history. But with the script, the material is more readily available. So you don't have to look at the history in R. You just have your script that is ready to be launched again if it's needed. So let's open a script here, and let's click on File, and then we select New File, and then in the window, File, New File, in the window we select R script, which can be opened also by pressing Ctrl-Shift-N. Remember, I suggest you that when an interface, a user interface like RStudio, has shortcuts, which means that they are quicker ways to do something through a combination of keys on the keyboard, I suggest you to make an effort not to ignore these shortcuts, because I mean, if you learn shortcuts for the actions that you frequently make on your PC, it turns out to be very useful to improve your efficiency. I'm not sure if I already discussed this issue, but remember that one of your strengths when you will be a professional, and also it's also strength now during your student career, is efficiency. So efficiency is something more with respect to the knowledge of the theory and the knowledge of the methods. Efficiency is something that it's an additional quality, which allows you to save some time during your work. And this is extremely useful because, efficiency, it's a quality that it's not so diffused. I mean, there are several people that can do one given thing, but a few only of these people can do it quickly without compromising the quality. This is efficiency. You do something in a quicker way without compromising the quality of what you do. Because, of course, everybody can be quicker by, in a way, compromising the quality. Of course, the strength, which is efficiency, is the ability of save time without compromising any quality. And this allows you to be more productive. And at the end of the story, when you are a professional, keep in mind that the agencies, the institutions, the industries, they look for persons who are efficient. Because if you don't meet the deadlines, you are quickly discarded by the list of the possible providers. And so meeting the deadlines is an essential strength, and it is gained through efficiency. And shortcuts, I go back to my original consideration, are, when you work on the PC, are very important to improve your efficiency. So now I click on R script, and I open the script that you see on the screen, left upper part. But I could have opened, let me close it, also with, I think it was Ctrl-Shift-N. You see, it was much quicker. And remember, when you work on the PC, there are actions that you may take in one day 100 times. And if any time you save 10 seconds, you can easily realize that within 8 hours of work, you may save easily half an hour. And half an hour every day means that you work half more day during a week. So it's not something negligible. Okay, now I open my script. Now let me go back to the proposed script, because what I want to do even today is to look at the proposed script and use it. As I said, the first part of the script are comments. I suggest that we can skip them, but I suggest that when you work on a script to copy also the comments, because they are kept in the script. When I work directly on the console, I said it's meaningless. It's useless to cut and paste the comments. But in a script, the comments are useful because they allow you later on to remind what you did. So let me just put them into the script. And you see that in the script, the comments are written in green because it's a way for the script and for RStudio to tell you that these are not instructions. Now that I placed something in the script, let me save it. And save can be done by clicking on File and then Save. But you see Ctrl-S. So let me just use Ctrl-S, which is a shortcut. And let me save it wherever you want, okay? So, and let me put a file name, and in my case it's temporary.txt. I suggest that you use an extension R for the script. So it is immediately recognized when you click on it by RStudio. And then let me define the utility functions, and let me just copy and paste all this part just at one time, and also with the comments here. I'm just doing it very quickly because I think there is nothing that is left to say on the definition of these utility functions. Look, the way these utility functions are placed into the memory of R, so the whole group of instructions that I'm cutting and pasting now can be changed. I mean, you can find another solution to memorize the utility functions in R, and maybe you can find a more efficient solution. So you are not obliged to follow the route that I proposed. This is an example which allows you to get to target, but on the other hand, it's not the unique alternative. You may find a more efficient solution, and you are welcome to dedicate some thought on it, okay? Now, let me just copy these instructions and paste them here. Okay, very good. Let me I forgot to copy this part of the comment. I'm copying it. Oops, sorry. Copy, perfect. I go back here. Please see. Okay, very good. I am saving, Control S. Now, let me copy also these instructions. And what is what I'm copying? What is the purpose of these instructions here? It's to define the elements of the matrix of the pairwise comparison. I just would like to remind you that this matrix has units on the principal diagonal, and in the opposite position has given numbers which are the scores of each pairwise comparison, and in the opposite positions in the matrix of these numbers, we have to put their inverse, the inverse of these numbers. Last time I made a mistake, I called it Anti-Symmetric Matrix, which was a mistake. And I didn't find any name for this matrix, which what I would like to say is that, let me just go on the blackboard, if it's possible, yes. This matrix, let's suppose it's a 4x4, okay? So, as units on the principal diagonal, and then when you get a position, so in this case, the position is in the matrix is this number. Let's put a 7 here, and its position, I put the indication of the position here is row 1, column 2, okay? Now, in the opposite position, which is row 2, column 1, I have to put the inverse, 1/7, okay? And so basically, in this way, you make the matrix, let's say, appropriate to describe the pairwise comparison between each pair of criteria, okay? And in our case, these numbers are put according to what you see on the screen. Just notice that what we do is just to first put diagonals at unit value, copy. First, I have to define the matrix, and the matrix is defined through the instruction array that you see on the screen, the first selected line. And then I have to put the other diagonal elements. I put it in the script, paste. Remember, what I'm writing on the script is not yet passed through the console. If I want to pass the script through the console, what I have to do is to press run. Let me see if Okay, run is just the current line. So in order to pass the whole script through the console, I have to first select it. I make a selection of the script and then I press run. Why should I pass it through the console at this stage? Just to check that there are no mistakes. So if you go on the console and you see the results, you can scroll it up and down, and you see that there are no errors, no reported errors. So this is a check that you can make that your script is working fine. So what I did so far is to define the matrix and put ones, units, in the principal diagonal. Now I have to define the scores of the pairwise comparison, and these are defined here. I am selecting the rows, and you see that we are working in a way that the comparison between the first and second criteria gives a score of 1, which means equal importance. And then we compare the first with the third with a score of 3, and then the first criteria with the fourth. And here I give a score of 1/3, which means that the fourth criteria is more important than the first. And then when I make, let me copy and paste this, copy. And by copying these instructions, I performed all the pairwise comparison that I needed to make. And now I have to make sure that in the opposite positions, which I have identified here, in the opposite position, I have the inverse of the numbers that I have just included in the script. So let me, and this is done here. You see that here it's nothing else than computing the inverse of the results of the pairwise comparison that is placed above. And now the matrix is ready. Let me copy this, copy, and let me paste it here. Now the matrix is ready. And let's select the script and run it, okay? So I'm selecting the script and run it. Okay, just 1 second, okay. Let me clean the console. If I want to see the matrix, I have just to write the name of the matrix in the console, not in the script, because it's not something that I needed to keep into the memory of my code. And you see the matrix here, which is fine. I mean, you see that in the opposite positions, you have inverse numbers, and there, it's okay. And now we can work with this matrix. One thing, in the script here, you see scores related to the pairwise comparisons. These scores are subjective, so you can try different scores. The only thing is that you have to make sure that the requirement of having inverse numbers in the opposite positions is met, but you can put whatever score you need there. And of course, we talked about coherency. When you make these pairwise comparisons, you have to be coherent. So if you say that money has equal importance, the benefit has equal importance with respect to, let me just make a check on the text of the, I'm looking for the PDF, which I can't find anymore. So I open it again. So if you say that the economic benefit has the same importance on the impact of the fish community, and the economic benefit is much more important than the impact on the landscape, this means that, in turn, the impact on the fish community is much more important than the impact on the landscape. I repeat what I just said. If you say that the economic benefit has the same importance with respect to the impact on the fishes, and the economic benefit is much more important than the impact on the landscape, indirectly, This reasoning implies that fishes are much more important than landscape. This means coherence. This is what coherence means. And you have to be careful when you make your pairwise comparison to be coherent. But otherwise, you can put whatever scores you want there. And we will make an attempt now that we have the script, we will make an attempt to change these scores. It's no problem, okay? Very good. Now, let me go to the script. And now here there is the computation of the eigenvectors and the weights, and there is also the computation of the consistency index, consistency ratio, sorry. Consistency ratio that should be less or equal than 0.1. Now let me copy these computations. I put them in the script. Okay. And then at this stage, if we run the script, we can check what is the value of CR. Good. Now let's run the script. And I take this opportunity to, let me clear the console, to tell you that you have two ways to run this script. One way is through the run button. You see my mouse now is on the run button, but in this case, you run a single line only. If you want to run the full script, you have to, as I did before, select it. Okay, now there is another way to run a script, which is source. You see my mouse is on source, and source, the help says that it sources the contents of the active document. So let's try source, and you see that in the console, only one instruction appeared. This instruction basically says that the whole script was run. Let's see if CR indeed is there. And in fact, you see that the value of CR is 0.01, which is less than 0.1, so the matrix is consistent. Very good. Now, we said, let's make another attempt. And what we did last time, let's create a different matrix with just random numbers. Okay, so I'm not bothering, I put here random numbers, 7, 1, 3, 1, 7, 5. Now, automatically, the conditions are satisfied, the conditions of units in the diagonal and inverse number in the opposite position are automatically satisfied by the code. So now I can rerun the code source, and let's see what is the value of CR. 0.56, it's not consistent. Of course it's not consistent because I just generated random numbers, okay? Let's try to make another attempt, again random. 1 here, 2, 1, 7, 5, 1. This is random again. Source, CR. Sorry. I typed CR in the script, which is not good. 0.6, again, it's not consistent. So this clearly explains what consistency is. Now I press Ctrl Z and I go back to the previous configuration. Ctrl Z is undo, okay? Good. Okay, so now let me run the script and check that everything is fine, because this is my matrix, original matrix. Indeed, CR is 0.02. And then we are ready, we understood what consistency is, we are ready to move forward. And let me see what are the weights. The weights, let me clear the console, pesi. Here are the weights which I already saw last Monday. Is there any questions so far, students? Because now we are completing the exercise by computing the score for each alternative, which is something that we didn't do last time. Any question? Just 1 second, I'm checking how many of you are attending the lecture, just to, and also I'm checking the chat. Yeah, 12 students, good number. Thank you very much. Okay, no questions. Very good. Let me go back to my remote PC. Okay, now let me go back to the script. And now what I have to do is multiply the utility function and weights. So basically what I have to do now? What I have to do is to compute the score of each alternative. So let's go to the web page in order to remind you on the theory. Okay. Also, I want to use the same symbols and language. So I want the figure. Just 1 second. Okay, in this example here, which refers to a different exercise, a different problem, you see the 3 alternatives in the bottom. In our case, we have 5 alternatives, which are 5 design flows. Here I have only 3 alternatives, 3 different interventions. And what I have to do now is to compute the utility of each criteria times the weight of each criteria. I just want to show you on the blackboard what I mean, okay? 1 second. So basically, you have 4 alternatives, which are, let me see, in our case, the alternatives are I don't remember the design flow of the alternatives. 80, 90, 100. So you have one alternative, 1 is a design flow of 80. And then you have alternative 2. And alternative 2 has a design flow, is a design flow of 90. Alternative 3 is a design flow of 100. Alternative 4 is, this was 100, 110, and alternative 5 is 120. Let me see if you can see the blackboard. I want to make sure that you see it. I think it's maybe better if I use the other camera, because I'm not sure you can see it well with this camera. It's a wide perspective camera, so let me see if I use the other one. Okay, let me see what is. I have, of course, to I think you should see it better now. Of course, I see it mirrored, so I hope that you can see it not mirrored, but I think it is fine. Okay, very good. If you have any problem in seeing the blackboard, please let me know, okay? And just 1 second, I want to check. Okay, very good. Now, these are the 4 alternatives. Each one of these 5 alternatives, each one of these alternatives has to be evaluated with according to 4 criteria. Okay, so and this means that each alternative has 4 utilities, 1 utility for each criteria. So the alternative design flow of 80 is characterized by a utility of the criteria 1, let's call it U1, a utility for the criteria 2, let's call it U2, let me just check if I am into the blackboard, yes, and then utility 3, and then utility 4. Let's call it U1, 1, where the subscript 1 refers to the first alternative, while numbers between round parentheses refer to the criteria, okay? And let me see if everything is, you can see everything here. The last one is a bit, just 1 second, okay. And then here we are. Now you see everything, very good. Okay, so I repeat, each alternative is characterized by 4 utilities, 1 per each criteria, okay? So it may happen that the alternative 80 has a low utility for the first criteria, which is net benefit. And I say low utility because the net benefit usually increases for increasing design flow. Very good. But this first alternative, design flow 80, probably in terms of the second utility has a high utility, because the second utility refers to the fisheries. And therefore fishes are happier if you took less water from the river. So probably utility 1 is low, but utility 2 is higher. And then you have the impact on, I don't remember, I think it's landscape. And again, impact on the landscape for a low design flow has a high utility probably. And then there is the last one, I don't remember what is the last one, let me check. It's, yeah, tourism. So for tourism, again, probably you have a high utility for a low design flow. So the alternative, design flow 80, has a low U1, probably, higher U2, higher U3, higher U4. And then how can I compute the global score? I need the weights. So I compute utility 1 times its weight plus utility 2 times its weight plus utility 3 times its weight plus utility 4 times its weight. And now 90. 90 is the second alternative. So I have to compute W1 times U2 of 1 plus W2 times U2 of 2 plus W3 times U2 of 3 plus W4 times U2 of 4. And I have to do this for each alternative. Good. Now remember that I can express this computation through a matrix, through an operation that uses matrices and vectors, okay? Because this is a summation. Of course, I can compute each one, but it's better if I use in R a multiplication of a matrix with a vector. And what I need then a matrix of the utilities, and therefore what I need to create is simply a matrix that is composed in this way, U1 of 1, and here I have U1 of 4, and then I have here U4 of 1, and here U4 of 4. And then I need to compute this matrix for the vector of the weights W1, W2, W3, W4. Okay, let me check if everything is into the blackboard. 1 second. Yeah, let me just, here we are. Okay. And this is precisely what I'm doing now in R. Let me go into my script. The script is here, and you see that indeed I am now computing a calculus, a computation through matrices. And what I do is precisely to make, let me copy this and then I make the comment on the script. Oops, sorry. Script is here. You see that I am multiplying here a matrix of utilities. In this case, I took the transpose because the way I composed the matrix of utilities in this script requires me to take the transpose. And this matrix is transposed matrix is multiplied by the vector of the weights, like I did here on the blackboard. Now, you may wonder whether why I composed the utility matrix in this way, so that I need to take a transpose. Of course, you can avoid it. And let's look back at the script where I composed, let's go where I composed the utility matrix. The utility matrix was composed here. After entering the utilities of each alternative, I composed vectors with utilities of each alternative. So the vector U80, the first line that I selected here, is composed by the 4 utilities corresponding to the alternative design flow 80. So I computed 4 vectors, each vector, I repeat it, containing the utilities of each alternative, and then I put this vector together. rbind is an instruction that combines vectors into a matrix. Of course, I could have used, instead of rbind, I could have used the instruction, let me change it here, cbind. Cbind is column bind, rbind is row bind. And in this case, I would have built the matrix by changing rows with columns. So I would have built directly the transposed matrix. So you can use this solution if you want. Instead of rbind here, you can use cbind. And then here, this instruction you may avoid to compute the transpose. But my suggestion is that it doesn't change anything. And so don't be bothered by, don't be reluctant to learn several alternatives with which you can complete a task. So our first alternative is what I used. I built the matrix by binding rows. And then here I needed to compute the transpose. A second alternative is to build the matrix by binding columns, and then I don't have to compute the transpose. Knowing several alternatives allows you to learn more instructions. So here we learned how to compute the transpose of a matrix. And knowing several different alternatives allows you to choose the most efficient one. So just don't be bothered by if you see several possibilities to complete a task, don't be bothered by inspecting all of them, especially if it doesn't take much time, okay? Now, let's see, at this point, let's go back to the script here, and what I obtained with this multiplication is a matrix of which I have to compute the sum of each row. Let me copy and paste. And let's now run this instruction first, prova 3, which is the multiplication of the transpose of u times the weights. Let me run it, and let's see what is prova 3. Oops, sorry. So you understand that we indeed obtained a matrix. And this matrix, you see that contains in each column the multiplication of utility 1 times its weight. This is what is displayed here. Utility 1 of the alternative 1 time its weight. And here it's utility 2 times its weight, utility 3 times its weight, etc. So it's clear that in order to compute the overall score is utility 1 times its weight plus utility 2 times its weight plus, etc. I have to compute the summation of this column. Oh, sorry. The summation of this number plus this number plus this number, etc. And this is precisely what this line of the script does. I am selecting this line and I run it. And in fact, if you look at the console, now what you see is, look at the console, the result of 0.08 plus 0.15, which is 0.23, more or less, plus 0.07, 0.3, plus 0.012, 0.4243, exactly the score here. This is the score of the alternative design flow 80. Good. Let's pass to the second alternative and let's compute its score. It's 0.36, it's lower, which means that if I go with the second alternative, you know, I get a score that is lower with respect to the first one. So the preference is still for the first. Let's now go to the third alternative, run. The score is even lower, so no good. So let's go to the fourth alternative. The score is lower, no good. Fifth alternative, score even lower. So the preference is for the first one, okay? Let's clear the console and let's summarize all of them. I select again here and I run it. Good. I think that this is the final result. So the preferred solution is the first one, design flow of 80. Of course, if you change your preference and you give more value to the net benefit, you could get a different situation. So let's go up in the script. Let me clear the console and let's make this attempt. Let's go up in the script and give more weights to the net benefit. And let's try to put then here in the comparison between net benefit and fisheries, let's put 7. The net benefit is much more important. In the comparison between the net benefit and the landscape, let's put 7 again. It's more important. Net benefit with respect to tourism, let's put 7 again. Good. Now, in the comparison, in the other comparison, let's put 1s, because they are, let's consider them equally important. I think the matrix, probably it's consistent in this way. Let's see. It looks to me that it's consistent. Now, let's source the whole file, and let's see CR. The first thing that we have to do if my evaluation is consistent. Yeah, it's close to 0, so it's consistent. Very good. And what I did is to give to the net benefit a much higher weight with respect to the other criteria. And the other criteria, I placed them at the same level. So this is an easy way to make the matrix consistent. Now let's see at the results then, okay? Because everything else is fine. I already ran everything. Let's compute these results, run. And now you see that the preferred solution is the highest design flow. Perfect. Because the highest design flow is that gives the max net benefit. And given that I gave much priority to the net benefit, this is what I expected. Do you have any questions so far before I make another attempt? Okay, let me clear the console. One may say, of course, you got this result because you put the net benefit as a very high priority. Now, let's try with the priority 3. So the net benefit is moderately more important than the others, and the other at the same level. Very good. Now, let me source the file. And let me see consistency first. Consistency will be fine, 0. It's fine because, you know, I put all of them at the same level with the net benefit with greater importance. And now let's run these 4. And what you see is that now the preferred solution is the design flow of 100. This is the preferred solution. Why? Because I gave to the net benefit priority, but not much priority with respect to the other criteria. And therefore, of course, what comes out is a preference for a middle solution. So you see that this is an extremely powerful way to translate into a decision the result of a series of very easy comparisons. I think it is an excellent demonstration of the value of decision theory. And this is also very easy to show to your stakeholders, and possibly through a figure. This is what you should do. This is my advice for you. Just use pictures, not use RStudio or numbers. It's numbers at the end is fine, but if it's even better if you translate numbers into colors, like the preferred solution with a green light, the intermediate solutions with a yellow light, the worst solutions with the red light. It's much better. But you understand, also keep in mind that, for instance, Excel has the capability to automatically color the cells depending on the value that you put into them. So it's very easy to translate these results into colors. Of course, I'm not insisting on that because it's not the purpose of this subject. The purpose of this subject is not to find the way to find the best relationship with your stakeholders. The purpose of this subject is to learn the theory, okay? But I really stress the conclusions, and I think that probably you may have been a little bit puzzled by the development, because when we talk about matrix calculus, when we talk about computing the eigenvalue, eigenvector. Of course, there is the risk that you don't see the connection with your purpose, with the reality, with the real world. But I hope that this demonstration, that now that you understood the theory, once that you built a code, it's extremely easy to pass from the theory to the practice. It's extremely easy to be able to use your results in practice. And I hope this provides to you a little bit of excitement, because, I think that motivation, excitement to study a theory is nothing else than seeing for an engineer the possibility to apply the theory. So I hope that this allows you to get the meaning and the purpose of dedicating a little bit more than 4 hours to this subject, which I think it's extremely powerful. Good. Now, I think we can close this exercise and close our discussion of the decision theory. So while I turn off my RStudio, etc., please feel free to ask questions, and better if you step in with the audio, because I cannot see the chat now. I'll be able to see it soon, but not now. Questions? Okay, now let me change the camera. Good. And let me go back to the web page of our course, which is going towards its end. And there is one final topic that I would like to discuss with you, which is the final link that you see here, saltwater intrusion. Now, let me provide a little bit of a context why this topic is interesting. As you know, I made a mix in my discussion with you about a mix of applications, theory, and I tried to always start from the applications whenever it was possible, and in order to provide the justification for also proposing to you the study of some theories. And when we spoke about application, actually, we spoke about assessment of water resources availability, and we spoke about technical design to some extent with a low level of detail, but still technical design of river barrages. And now I want to close with another, let me call me application and slash technical problem, okay? And because I really would like to close our discussion with a reference to a technical problem, which is much important in water resources management. So, of course, this technical problem may require the application of decision theory in order to find the best solution. This technical problem may require an assessment of the impact of climate change, because it's a technical problem, saltwater intrusion, that is heavily affected by climate change. It's a technical problem that may require an assessment of the human impact, because saltwater intrusion is heavily affected by human impact. And also, I think it is a nice technical problem. It's interesting because it has a relevance, an extremely high relevance to water resources management in a particular region, which is the coastal areas. We talk about saltwater intrusion, and so you can easily understand, you can easily perceive, and you can easily get that we are talking of salt water, and therefore water that is present in coastal areas. It may be coastal areas of open sea or ocean, or coastal area of salt lakes. So basically, what is fascinating of the coastal areas is that they are extremely important for our society, for the human life and the human future, because more than 60% of the world's global population lives in coastal areas, which means they live in a range of altitude between 0 and 100 meters over the sea level. So the majority of the world population lives in this very small range of altitudes. And for obvious reasons, because the coastal areas are extremely favorable to human settlements. Because, sorry, let me say one thing. There are in the world only 28, I don't remember if they are 28 or 48, but anyway, a very limited numbers of countries that are so-called landlocked, which means that they don't have any direct access to the sea. All of these countries have an economy that is suffering a lot. And the reason is precisely the fact that without coastal areas, their economy cannot benefit of the several advantages, of the several favorable conditions to human settlements in the coastal areas themselves. So what are these favorable conditions? And I started my sentence just a minute ago by saying because. Why the coastal areas are so favorable? Because, first of all, there is a direct access to fishery, which is a relevant source of food. There is a direct access to trade, because especially in the past, but also today, the seas were very important for the trade of goods. And, these are typically flat areas where the climate is particularly smooth. It's not a rigid climate in most of the cases. And therefore, all of these conditions put together create favorable conditions for the human settlements. And in coastal areas, of course, humans, like everywhere, need water. And they cannot use the water from the sea. They cannot use salt water. For obvious reasons. Keep in mind that we know that 70% of the water used by humans is for agriculture. And of course, you cannot use salt water for that. Remember that salt water cannot be used unless you desaline it for civil use. So it's water that cannot be used. It's not fresh water, so cannot be used for all the purposes where fresh water is needed. And therefore, humans, when settled down in coastal areas, they needed to get fresh water. And the moral of the story is that there are two ways for getting fresh water for humans. It's through groundwater or through surface water. And there are also additional ways like desalination, but in a classical settlement, in the traditional settlement, these are the two main sources, groundwater and surface water. So either they collected water from a river or from the underground. But the river is not always available. Of course, they tried to settle down close to the coast and close to a river. But as I said, the river is not always available, and the river is more prone to pollution. So an obvious and safer solution is to get water from the underground. And the moral of the story is that if you get fresh water from the underground, you run the risk of getting saltwater intrusion. Why? Because, water, when it's contained through a barrier, like a coast is a barrier for water. Water tries to infiltrate, of course, because the water is under pressure. If you go deep into the sea, water is under pressure. And therefore, if it's pressured, water tries to infiltrate into the coastal areas. And this is very often facilitated by the fact that coastal areas are alluvial areas. The permeability of these soils is very relevant. And therefore, what is opposing the infiltration of salt water into coastal areas, if not the imperviousness, which is infrequent? I state again my question. What is opposing the intrusion of the infiltration of salt water into coastal areas, if not the imperviousness of the soil, which is infrequent because they are very often alluvial areas? The only force that opposes is the flux of fresh water from the land. From the land in the underground, if the underground is permeable, you have a flux of fresh water because the land is higher than the coastal areas. So when it rains over the land, you get water in the underground that flows down, flows towards the sea. And therefore, in the coastal area, we have an interface. The salt water from the land and, the fresh water from the land and the salt water from the sea. I'm now showing you a picture. This creates an exciting environment, exciting especially for a scientist, because it's something that has a dynamics that is based on the opposition of two driving forces. Let me go to our web page. And here there is an introduction explaining what saltwater intrusion is. And I already made this introduction. But let me, before focusing on here, let's look at this figure. Before focusing on the causes. 1 second. Okay, this figure may not be easy to understand on the screen, but let's look at the dark blue, which is the ocean, and let's look at the light blue, which is fresh water in the underground. So if you look at my mouse, you see that there are, let me see if you, yeah, my mouse is visible. There are arrows that indicate the direction of the water flow of the fresh water into the land. And then there is the salt water on the right from the sea. And then you see that there is a zone which is a mix between light blue and dark blue. This is the zone where you have infiltration of salt water that is mixing with the fresh water. And usually we identify an interface, which is, it's a conceptual schematization, because there is not there is a mixing zone rather than an interface. But we identify usually a limit in the underground beyond which the salinity of water is low, and then the water can be used by the roots, by the vegetation, and by humans. And in fact, you see that the roots of the tree get in the deep soil until they reach this interface. They don't go, the roots don't go into the salt water. So this is the scheme. And as I said, it's really exciting. Let me show you another figure, because this one, it's you know, it's not easy to understand. I want to show you 2D figure. Just 1 second. And let me see, I think I have another one. Okay, this one I think it's the best one. So you see the land, the fresh water under the land, the sea, the salt water, and you see that from the land you have the arrows indicating the flux that clearly say that the water is flowing toward the sea, but you have also the salt water that is trying to intrude into the land, and then you get to a zone of dispersion. This is the interface I was talking about. And in this zone of dispersion, of course, you cannot put the roots of the trees, and you cannot put wells to get water. And what is the problem? The problem is that for some reasons, if you for some reasons decrease the amount of fresh water in the underground, perhaps because you are pumping it, of course, what happens is that you are reducing the strength of the freshwater flow. You are reducing the driving force of fresh water. And if you make fresh water weaker, then salt water prevails and intrudes more. So this is the problem of saltwater intrusion. Saltwater intrusion is something that we are very concerned of, because if salt water advances in the underground and reaches the wells, reaches the root of the trees, then there is a contamination of our freshwater resources, which imply that they have to be left out, they have to be abandoned. And, this is a problem. This is a problem. So we are concerned by all the reasons that may bring salt water to prevail. And what are these reasons? Let's go up in this web page. Let's go up here and let me reduce it. So here there is a schematic representation of the natural saltwater intrusion drivers, natural, okay? And these are not induced by humans. And you see them represented with respect to their temporal and spatial scales. The temporal scale on the horizontal axis, the spatial scale on the vertical axis. And then you see that the causes may be hurricanes, of course, because if you get high waves, it means that you have a higher pressure of salt water, seawater over the ground. Tsunamis, same thing. Drought, why drought? Because if you have less rainfall, you have less fresh water into the land, and therefore decreasing strength, decreasing pressure of fresh water, and then salt water prevails. Climate oscillations means natural climate variability. We know that during glaciations we had the sea level that was more than 100 meters lower with respect to today, and therefore less strength for salt water, less saltwater intrusion. And then there is climate change. Climate change intended as sea level rise. Climate oscillation is intended, I mentioned the sea level, but I was not correct. It is intended to be changes in the rainfall regime. But then there is the climate change related to the sea level rise, which I mentioned before. And then there is subsidence. Subsidence, if you lower the level of the land, this is subsidence, then you get, of course, less water in the underground. And then there are the human-induced change, again against the spatial scale and regional scale. So there is accelerated subsidence, groundwater abstraction, because if you take water from the wells, again, you reduce the strength. River modification, because, if you change the course of a river, you may impact the infiltration from the river. You may impact the surface water, groundwater interaction. And then there is the land use change. Land use change may imply less infiltration, less fresh water into the ground. Land drainage. Again, if you drain the land, you have less infiltration. And then human-induced climate change, exacerbated climate change. These are human-induced drivers. Now, what is the role of the engineer here? Of course, the role of the engineer is to design solutions. If we are concerned by saltwater intrusion, we have to design solutions to resolve the problem. And we have several possible solutions because you see the drivers are several, which means that you may have several solutions. Very good. But first of all, the engineer needs to study the dynamics of it. Because in order to find solutions, an engineer needs not only to know the problem, but also to model it, to represent it, to quantify it. We need to locate the position of this interface in the underground between surface water and salt water. If we want to say to a person, you shouldn't make a well here, we have to support this statement with a quantitative knowledge of what is going on in the underground. Good. Here there are some figures that represent what may happen after human intervention, for instance. So, again, we are talking of drivers here. This is pristine situation, what you see on the screen in the lower part of the screen now. And then this is the perturbed situation. If you place wells there, because you have to feed houses, etc., what happens is that the level of fresh water goes down. You see, the light blue goes down. And then the salt water prevails. You see this wedge that I am now highlighting with the mouse in the upper figure. This is a wedge of color, which is in between the color of the salt water and fresh water. And this is another wedge that is located deeper. And these wedges in the perturbed situation advance into the land. This is the so-called saltwater wedge. And it is the reason of our concern. This is water with higher salinity with respect to fresh water. It's water that we cannot use. So we need to keep this wedge small, as small as possible. And now we have to identify a solution for containing this wedge. Okay, we already talked about this figure. And how can we set up a model for describing this problem? It's a model of the groundwater dynamics. It's indeed groundwater, partly salted, partly fresh water, but it's indeed groundwater. So we have to apply a groundwater model. And we already know the groundwater equation. The groundwater equation allows us to describe groundwater flow. In this case, application is a bit more complicated because we have two types of water. We have to describe also the salinity. And therefore, we have an interface between two types of water. And actually, it's not really correct to say only two types because it's a mix of water with different levels of salinity. But if we want to split it in two broad categories, it's seawater and fresh water. And in the interface, there is a mix of the two, as we already know. So it's a model that becomes a little bit more complicated because actually what we have to do is to describe groundwater flow and flow of salinity. The groundwater flow equation is already a bit complicated, and you understand that in this case becomes even more complicated. And it's a 3D problem because we know that groundwater models are framed in 3 directions. And also it's, just one second, okay, somebody opened the door. Also, what I want to say, it's a model that it's an environment that is difficult to describe for like any groundwater environment, but in particular within coastal areas. we have a lot of heterogeneity, precisely given by the fact that we have this interface, and then we have also the solidification of some salt in the underground. So it's an environment that is difficult to describe. So we need to simplify the problem. We cannot, usually we don't apply a full groundwater 3D model for studying the problem, at least in the preliminary phase when we want to get a qualitative assessment. And we need to adopt a simplified problem. And this type of simplified problem is precisely what I want to describe now. And the first simplification that we made is to reduce the dimensions. So we reduce the problem to a 1D flow and not a 3D one. And by reducing the problem to a 1D flow, we can apply the Darcy's equation, the Darcy's law. And this is a first simplification. So we may reduce to a 1D flow that we can study with Darcy's law. If we want to simplify the problem even more, then we refer to static conditions. So conditions that are not changing over time. And so a condition where you don't have flow in particular. So you study the equilibrium between two bodies of water in a static setting, no flow, and we assume that the interface is just there is no zone of dispersion. I have a sudden interface between salt water and fresh water. So I reduce to study the equilibrium between two water bodies without allowing any mixing. And this makes the problem simplified. So this is what I want to discuss with you on Monday, and starting from a brief recall of the Darcy's law, and then we will study this hydrostatic equilibrium between these two water bodies. I just would like to say that on Monday, I think I will dedicate to this lecture a little bit more than the first hour, and then we will pass to an overall recap. For today, I think I can close. I wonder if you have any questions, students. And I am, meanwhile, closing any window. I am stopping in just 1 second. I see something on the chat. Yes, this question is, the answer is yes, which means that the water flow is based on the hydraulic head. Yes, correct. And so high tides may facilitate saltwater intrusion. But just let's consider one thing. If you have high tides that are part of the normal regime of the ocean, this is something that it's already contributed to creating an equilibrium. So we are bothered by situations that may perturb the equilibrium which was in place when humans settled there. So if the high tides were already there when humans settled down with the same dynamics, then of course humans adapted to it. And therefore the wells are already placed in a position where they are not affected by the tides. But if for some reason the tide level is increased, and the reason may be also land subsidence, okay? So the situation changed with respect to the past, then of course also the increase of pressure given by a tide, which didn't concern people in the past, now in the new situation may bring concerns. So indeed, reducing, if one could, reducing the level of the tides for sure reduces the extent of the saltwater wedge. Usually we refer to climate change for this, and climate change implies an increase of sea level, of course, and the increase of sea level with respect to the past is quantified with respect to the pre-industrial period, as we have already seen, is quantifiable in about 15-20 centimeters, depending on the coastal area. And this amount of increase is not particularly concerning for flooding, but 15 centimeters of increase with respect to the extension of the saltwater wedge are important. And for some reason, when people talk about problems caused by sea level rise, they talk about coastal flooding because it's more impressive, It means that people are dying. But actually, coastal flooding, 15 centimeters more of sea level in terms of coastal flooding is nothing. But in terms of saltwater intrusion, as we will see on Monday, it's extremely important. But for some reason, it's not frequently mentioned as a problem for climate change. Okay, and let me stop the registration. And if you have any other question.